Hi, everybody, and welcome. I'm a facade design engineer, JEI structural engineering, and we've been doing facade and glazing systems design for approximately 17 to 18 years. So we're going to go ahead with that and move forward in our presentation about thermal bridging at facade connection points. So we're going to cover a little bit about the importance and code changes that are evolving today. An important new code that just came out in October. We're going to also cover a little bit about thermal bridging reduction associated with steel structures. And then one of the biggest changes in 70 years for facade support connections to steel structures that's associated with thermal bridging. So basically, thermal bridging is whenever you've got an object or a component that has a clear path for heat transfer, and it's got less resistance than the other parts around it. Thermal bridging is really important whenever you get into talking about the energy needed for heating and cooling, and that's why it's become a very big important part of new codes and future code developments. And so this is a little excerpt out of the 2020 April Glass Magazine article. And it basically identifies that ASHRAE 90.1 came into being in October 2019, and it upgrades requirements associated with thermal performance on all types of facade systems. And so inside of this article, they addressed thermal bridging requirements, and they're also putting a great emphasis on the change associated with future codes associated with thermal bridging requirements. Connection points at facades are becoming even more critical. In other words, in part of the Glass Magazine article, they identified that you can have the best performing glazing system that is out there, but if you don't address the connection points from the facade to the structure, then you're really not doing the part in the in bringing about the real reductions that you could and where the code is going to in the future. So this is a new concept in creating a thermal break associated with steel structures. We got the top of a beam here, and this is a continuous pour stop and anchor system that's on the market today. If we add a thermal break material, a structural thermal break material, we achieve an additional thermal break from facade systems of all sorts, including curtain wall, where we've got highly conductive aluminum material, thermally conductive aluminum material, and then we're able to add the break in so that it doesn't create a load transfer back into the structure. Some of the past, for at least 70 years, we've been doing things in the same way associated with steel structures, where we've got a steel bent plate pour stop that's attached onto the structure, and somehow we have to have a connection to support facade off of that. And so typically that would be a welded connection that has a direct thermal path back into the structure. And so some of the other disadvantages are that there's a high cost associated with field welding. Similarly, precast is supported, with something that looks like this. It's either this or a welded off tab connection, and that allows for direct thermal bridging into the structure. So traditional steel stud framing and light facades might look something like this, where we have steel studs and then you have some sort of a clip that is a metal clip, and usually it's attached directly into the pour stop, the steel pour stop, and that provides a thermal load path back into the structure as well. So we're talking about curtain wall, and usually with curtain wall that is stick built and also unitized, we have similar situations where we have a clip angle that's steel, and usually it is welded on to a steel pour stop associated with steel framing, and it provides a load path back into the structure. So we can see that, all the way back 70 years that we've been using these types of steel pour stops. Now this is a 1970s building, so it's 50 years, but for 70 years we've been having the same detail associated with the edge of steel framing, and this is a clip that is welded on for a curtain wall. So we've been messing around with trying to find ways of connecting around this steel pour stop that is connected onto the structure. And so there's really not a whole lot of choices associated with a bent plate pour stop. And that's kind of where this idea came from, and this new product where we have a continuous pour stop and anchor system, which allows for a bolted connection, and it allows for a new thermal break to be introduced in between the facade and the structure. Some of the other advantages associated with J-edge anchor system are it has more capacity to support facades. It actually has more capacity due to the better load path and due to the better, stronger steel in the extrusion process. That gives about an over 200% increase in structural capacity for supporting facades. It also offers a unique advantage that it's a bolted connection instead of a field welded connection, and it reduces the costly field welding and anchor installation mistakes. It also reduces construction schedule. The install time of one clip that's welded onto a steel pour stop is approximately about 15 minutes. And you have 2 clips per curtain wall mullion, and so this actually speeds the time of facade enclosure whenever you have a bolted system such as J-edge anchor system. It has a better tolerance as well. Since this is an extruded part, it is very, very straight. One of the common complaints that we have as facade engineers is that in the bent plate pour stop, it's rolled and it's usually very wavy in and out of the plane, and there's a high degree of tolerance that contractors need to make up for in construction. Another advantage to J-edge anchor system is in this area of construction where we have typical construction railing that is usually welded to the inside of this bent plate pour stop. And this usually gets just shaved off whenever they finish construction, and that allows for the waste of a lot of different material. So for J-edge anchor system, we actually have an adapter that has been developed for a safety railing system that's a bolted on system. And we can kind of see that this safety railing system in place is used in construction already, and it bends into the plane of the building so that curtain wall can actually be installed over it. Another advantage is in the area of handrail systems, allowing for easier attachment into the handrail systems. One of the major advantages to J-edge anchor systems may be in the future for reuse whenever you have a cassette type system with a toggle so that glazing can be taken out and reinstalled, combined with J-edge anchor system that has an adjustable bolt system on it. You may be able to have facades that are originally looking like this and then be able to reuse a lot of it to make a facade and transform it into something in the future like that. It also has many other support options, including all different facade type constructions and support, even with a thermal break in all of the situations that you see here. So this is with precast, we can have a thermal break associated with this, and we don't lose real estate with something like this where there's a loss of real estate with a traditional construction. For facade connections with precast, you can also have an underhung with a thermal break material included in it as well. For masonry construction, where you would have a typical ledge support angle, it can still have a thermal break associated with that in between the ledge and the J-edge anchor system, versus the field welding that would have to take place with some sort of support on a bent plate pour stop. For light gauge facades that are typical steel construction, where we had clip angles that are metal attached directly into the steel pour stop, we're now able to have a bolted system, and we can include the thermal break material in between those two. One of the major advantages, though, is the cost associated with J-edge anchor system. Ultimately, the increased cost of the part at this point is less than the deducts associated with all of the field welding that needs to take place to the traditional bent plate pour stop. So in this case, it's a real example of a 7-story office building, and they actually ran out this estimate to where there was a $200 credit deduct just for the curtain wall installation for all of the field welding that they would have to do, and that equaled a savings of $108,000 for the overall cost of the project. This doesn't include savings for the reusable safety railing, faster construction schedule, or the value of opening the office 1 month earlier. Multiple tests have been done associated with J-edge anchor system. Lots and lots of engineering analysis is associated with it as well. And we're able to use data from testing and engineering analysis, and we've got interaction load tables that are available for projects. So here's a summary. It has better thermal performance because we reduce the thermal bridging capacity associated with facades and their traditional connections. It's better structurally. J-edge has advantages for construction of all types of facade. It's got a faster construction schedule because you reduce all of the field welding, and it saves on construction costs. Here's some of the resources that are available to you off of the website. We have sample calculations, testing documents, AutoCAD files, Revit, RISA, and we have multiple videos that are associated with this product already. And so next action points are, you can get a free project detail, how this J-edge anchor system can be applied to your project in specific. And ultimately, it's available right now and in supply for ordering for you to specify on projects or to become a reseller of the J-edge anchor system. Here's our contact information.